So now we're going to talk a little bit about test stands versus load frames. So test stands and load frames, both mechanical structures, mechanical devices used for various testing, but they do differ in functions and designs. Where test stands would be more like a test bench or structure, a bed plate, for instance. These are designed, the whole rigid component, while you're subjecting them to forces and various loads. Load frames, for instance, on the other hand, are just machines designed specifically to load axial torsional forces and small component testing. Test stand definition. Use to hold test objects and devices and apply forces or torque to it. Typically designed to accommodate, a wide range of different test devices. You may be testing shocks one day, maybe you're testing seats another day. So they need to be very versatile and reconfigurable. Test stands may have various components, base plates, columns, crossheads to induce these various load requirements and how you're applying loads. They may be motorized, they might be manually operated to apply forces. Could be electric, mechanical even. Test stand considerations. So you want to ensure that you are, have a test stand that's properly sized for the type of testing that you're doing, the capacities, cycle counts, whether it needs to be fatigue rated, and any other type of extraneous load, considerations. Multi-bridge, that's good for redundancy. So if maybe you want to have a multi-bridge load cell, for instance, to have that redundancy and data validation. Thread adapters and connector protectors, we talked about that a little bit earlier. If this is going to be moved in out of the test frame and in various test frames, right, protection is key, and you want to make sure you ensure you consider those features when selecting a device. And then again, versatility, the multi-axis data capture. So yeah, if you need to measure more than one axis, then you would want to consider multi-axis load cells for the measurements, and then invest in versatility, right? If you can select a sensor that can be used in many different tests, then you get the better value there. Here's an application note for actual EV battery test. And in the graphic there, you can see there's a battery and its battery tray, if you will. It's being subjected to multiple forces and measuring reactionary forces. So, these types of tests, you can use load cells, multi-axis load cells, for instance, and you want to make tests like this for life expectancies against certain targets, crash survivability, things of that nature. And in this case, you can see we've used some of the single axis 1100 series ultra precision load cells. And then there's also some multi-axis load cells beneath it that are measuring the reactionary forces through the battery itself.
All right, thanks, Jeff. All right, so load frames. It's a little bit different than a test frame, right? We're considering a load frame essentially mechanical equipment that is specifically designed around a specific material test requirement. So typically it's going to be a specific tensile test, could be a torsion test, or it could be coupon testing. Typically speaking, these are going to be standalone devices that are not reconfigured between tests. So it's going to have a platen and frame assembly that's going to stay the same from test to test. Different grips, different things that might be added in for the different test articles, but the overall test frame architecture is going to stay the same. typically going to be much more rigid, and they're going to be much better aligned in a lot of cases than a test frame would be. And again, I touched on a little bit, but it's different accessories and fixtures dependent on the type of test. Could be a shear test, could be a flexural test, could be different material that requires different grips to be installed on the load frame to grasp the material. Considerations for these types of tests: concentricity and test condition control typically allows for increased precision. So that's touching on that alignment again. We're able to much better control that alignment there. So hopefully the off-axis and extraneous loading conditions are mitigated there. Size to capacity for the maximum resolution. Again, since we can control the off-axis much better in most cases, we can size the capacity of the load cell much closer to the actual test range that you're working on. Still want to evaluate what's going to happen if that DUT does fail, and what resonances or ring might occur if that thing breaks, if the DOT breaks, that is. Thread adapters can be a great way to reutilize an existing sensor for other applications. That's just adapting between different thread sizes. You can use the same load cell for multiple tests. Component upgrades for sensor and instrumentation and automation. So that's just looking at ways of getting more resolution out of the transducer itself, and potentially automating, in some cases, coupon movement and testing procedures. Multi-axis transducers are a great way of gauging how well the frame is aligned. So maybe it's a new frame, maybe you did some work on the frame, but if you can measure multiple axes, the example I would use would be a load cell that measures in a primary axial direction, and then perhaps the moments about X and Y of that primary axis would help you essentially gauge how well those frame platens and your load string are aligned. A lot of times it's very hard to ascertain, but that is a means of doing that. And of course, the better aligned it is, the more investment you put into making sure all of those, that load string is aligned, load frames aligned, best sensors. You're investing in trying to get the precision as high as it can be. So optimizing that measurement. Different examples of what we offer for frames. We've got a couple new developments here. This is our model IF and VF, intended for essentially field verification of load cells and systems. Simple hand crank adapter rated up to 5,000 pounds. You could theoretically do some calibration on perhaps lower performance load cells, but it's primarily intended for use as verification, where you just want to load a load cell and an indicator display up to a given load and check its performance. We do offer calibration load frames. So these are essentially completely self-contained calibration systems with a hydraulic power unit on the right hand and a piston on the left hand of that frame, designed around a very specific and very precisely aligned set of platens and columns. We use a 4-column design for stiffness, and have a unique load string system that allows us to load both tension and compression without having to break the load string. This will let you run a calibration run in less than 5 minutes, including report generation. For most folks, that reduces the calibration time by 50 to 90%. So about a 12-inch post-to-post clearance for load cell and DUT installation. And again, that's automatic report generation, and archive is a real time saver for most folks.